Hello, my name is Daniel Katz, and today I will be talking about our research into search term privacy. This work was conducted by myself and my colleagues David and Johan at Norton LifeLock Research Group. I wanted to start by discussing what motivated this work. Users understand that Google and other search engines collect their search terms and may sell them to advertisers. However, internal site search is different from search engines. The results are specific to that website alone. Therefore, users may have a different expectation of privacy. It is well known in the literature that search terms may contain sensitive information, for example, health, race, and sexual orientation. It's also known that advertisers collect sensitive information and use it to target ads. For example, the Cambridge Analytica used race to dissuade black voters from voting in the 2016 election, and numerous other examples. Our work studies the different ways that websites which contain internal site search may leak search terms, accidentally or on purpose, to third parties. In order to understand our work, we must first talk about referrers. A referrer is an HTTP request header that is automatically set by clients or browsers to indicate how the user found that website. For example, this screenshot shows a New York Times article on the news aggregator website Hacker News. When the link is clicked, a network request is initiated to the New York Times. We can see that Hacker News is included in the referrer header. The referrer policy is set by the website owner and specifies how the referrer header will be set upon requests originating from that website. It can be set in a number of different ways, for example, via the HTTP response header, but also via meta elements and inline inside the resource requests. This is a table that has a variety of acceptable values for the referrer policy. However, the default for many browsers was no referrer when downgrade, which in that case sends the full referrer header value, including any potential query strings, uh, if both pages are HTTPS enabled. Prior work has shown that referrer headers can leak search terms. The referrer values can contain query parameters, for example, search strings. To use a concrete example, we search for the medical condition pancreatic cancer on WebMD. When WebMD renders the results page, it loads the third-party JavaScript library Google Ad Services. Our query string is sent to Google Ad Services as part of the network request. Our primary research goal is to study the leakage of search terms in internal site search along three vectors: the referrer header, the URL, and the payload. To do this, we crawled the top 1 million websites according to Tranco, which is considered a better alternative to Alexa. We used a headless browser to simulate typing in jelly beans into search fields one character at a time. We intercepted ingoing and outgoing network requests, and we looked for the jelly beans string in the captured data to see which websites leak and receive our search string. Our crawler was based off the Puppeteer headless browser, and the architecture looks as follows. The workers are headless Chromium processes. The headless browser has full JS capabilities, which is required to crawl the modern web. Our setup can handle over 100 concurrent workers, which was necessary to crawl 1 million websites in a reasonable amount of time. To put it in simple terms, our crawler found all the search inputs on a given HTML page. Then it would type the jelly bean string one character at a time into that input, and finally it would execute the search. The crawler would record all network traffic for later analysis. We faced a number of challenges when running our crawler. For example, false positives when searching for search inputs in the HTML page, hidden search inputs, dynamically generated query selectors, search results displayed in a new tab, interstitials, captchas, and regional blocking. It took a significant amount of engineering effort to overcome these challenges. Now I want to present our main results. We crawled the top 1 million websites using the Tranco list from August 2020. We were able to search on and collect results for about 512,000 domains. Out of those, about 81% leaked search terms to third parties in some form. To answer a research question from earlier, the leakage breaks down as follows: via the referrer header, via the URL query parameters, and via payload, often in post requests. We will explore each of these cases in more detail. First, we look at leakage via the referrer header. The search terms are leaked in a direct manner on 72% of the websites we looked at via the referrer header. However, the search terms were leaked in an indirect manner on 10% of the websites that we looked at. To see how this might happen, take a look at the figure below. Notice that A loads B as an iframe, and B sends a network request to website D. In such cases, we say that B leaks the search terms to D in an indirect manner. Another way for the search terms to be leaked is via the URL query parameters. This happens on 71% of websites. However, there's a potential for leakage on 87.4% of websites. The idea here is that websites which display search results may contain a variety of links. When a user clicks on one of those links, in that case, this query string may be linked to that website's operator through a poorly configured referrer policy. To determine the potential leakage, we looked at the policy for the page and any element-specific annotations. The final vector that we looked at for search term leakage was via payload, which often happens via post requests. We actually observed payload leakage on 21% of websites. However, we did also observe obfuscated payloads on 0.9% of websites. For example, these websites might encode the query parameters in base64, which we decoded. We also observed many other obfuscation techniques, including exotic encodings. We observed some very large payloads in some cases, for example, over 10 kilobytes per request, which was a little bit suspicious. Finally, we would like to report on what referrer policies were observed in the wild. We found that for the vast majority of websites, no referrer policies were explicitly specified, either via their header or via HTML elements. This shows the great amount of influence that browser vendors have to control potential privacy leaks via referrer headers. Another element of our research was looking at privacy policies. We wanted to know whether users were informed that their search terms might leak to third parties. In order to do this, we extracted links to the privacy policies during our crawl. We then determined if the documents were actually privacy policies using a classifier, which we trained on the OPP 115 corpus using a one-class SVM. Then we looked at whether the privacy policies have any text relating to search. This is a subset of the OPP 115 corpus. It shows fragments of privacy policies that pertain to the treatment of search terms. Our results show that we were able to find privacy policies for 50.5% of websites in our dataset. 13% of those privacy policies mention search-related practices explicitly. However, a number of the privacy policies contain vague statements related to user interaction. From this, we can conclude that not many users would be informed of the potential for their search terms to be shared with third parties, even in the case where they actually read the privacy policy. I would like to conclude by talking about mitigations. For starters, the Brave browser does redact the referrer header, and Chrome version 85 Plus and newer versions of Safari only sends the referrer domain, not the query string, to third parties by default. This is something that they changed since the time of our crawl. But keep in mind that all these settings can be overridden by the site operator. In cases where this was not enough mitigation, we also built a browser extension which alerts users when a website shares their search terms with third parties. In conclusion, 92.1% of top websites that we were able to crawl had some kind of privacy leak through one of the three observed vectors, and often along multiple vectors. Website operators rarely specify the refer policy explicitly, so browser vendors have a large impact on user privacy. Privacy policies include little or no information about search terms, despite their known sensitivity. And finally, privacy policies on the web are still hard to find. We're only able to find privacy policies for 50% of top websites. Thank you for listening to this talk. Since we only had a limited amount of time, I only scratched the surface of our research, and I encourage you to read our paper for more details.